We just saw a very bare bones version of a singleton implementation. However, in the real world, singletons don't really look like that. There are a lot of subtle issues that you need to deal with. Let's take a look at all of these here and how we can solve them. Here is the code we had ended with in the last class. Let's take it from here. Now, if you've done any thread-based programming and used synchronized, you'd know that marking the getter as synchronized can lead to quite a performance hit. Having a getter as synchronized means that every thread has to wait before it can get an instance of the singleton, even if the singleton has already been created. This is a huge performance hit for no reason, because once the singleton has been created, you're kind of good to go. You can just access it, and the synchronized keyword on the getter is not really needed. So how would you get around this? There are two ways. One, you'd eagerly instantiate the singleton. You just instantiate it when the class was set up, and then you don't need to synchronize the getter after that. The second option is you'd use something called double checked locking, plus you'd mark the member variable which holds the singleton as volatile. So in order to avoid synchronizing the access to singleton, each time you get instance, even if the singleton has been instantiated, you can use one of these two methods. Let's look at an eager instantiation example. Take a look at the code that you see on screen. Notice that the singleton member variable is instantiated while it's declared. And then in the get instance, you simply return singleton. You don't have to have the synchronized keyword, and you don't have to have the if check to see whether singleton has already been created. The code looks a lot cleaner. Why would you not use this method? Now, if instantiating a singleton was a great performance hit or consumed a lot of memory, then you're instantiating it without anyone ever having requested for it. What if the code path is such that your application never requests for a singleton from external code? Then you've just instantiated, it's a waste. So you may not want to do this, especially if instantiating the singleton is a heavy-duty operation. Alright, let's see if we can figure out a better way to do this. Double-checked locking. Before we go into what exactly double-checked locking is, let's do a quick Google search and see what definition Google has to throw up for us. Here is some stuff from Wikipedia. Double-checked locking is itself a software design pattern. It is explicitly used in order to reduce the overhead of acquiring a lock. We already know that synchronizing access to any variable or portion of code is extremely expensive. So we want to avoid doing that wherever possible. Double-checked locking helps us do this by first testing some variable. Testing to see whether locking is really needed by testing something called the locking criterion or the lock hint. Now this test is performed without actually acquiring a lock. So outside the locked portion, you just check whether a lock is really needed. If it's not, you don't lock. If it is, then you lock the portion of code which you want to access. By performing this test, the number of times you actually need to lock access to a code is greatly reduced. Thus, it's a performance optimization and a huge help. Let's take a look at how code looks when we use double-checked locking. Look at how get instance looks right here on screen in front of you. We have two checks for if singleton equal to null. This singleton equal to null is basically the locking criterion or the lock hint, which is first tested outside the synchronized code. Only if singleton is null will we enter the first if block. Then we synchronize the entire portion of code after that. And then we check for singleton equal to null again. Why do we do this? If you think about it, the first check is to know whether we should lock or not. It's totally possible that once we determine we have to lock, some other thread might be inside that synchronized block and instantiating a singleton. So once we get the lock and enter the synchronized block, it's good practice to check again whether a singleton has been instantiated, because the thread which just exited might have created the singleton already. Which is why the double check. We check the same condition twice. So for double check locking, we have one check, and then we start the synchronized block, and then we have another check. What have we done here? We've checked the same condition twice with a lock in between. So we test before the lock and after the lock. Now, we've described double check locking, but it's also important that we mark the member variable which holds the singleton as volatile. Why is this needed? Now, Java has a very cool compiler which helps us in all kinds of ways, but sometimes it also gets in our way. And here is what can happen. If we have two threads trying to instantiate the singleton, it's possible that one thread comes in, instantiates the object so far that it allocates the memory of the object but doesn't initialize its variables. Then that thread may be swapped out, and then it allows another thread to now come to check whether singleton exists. Just because memory has been allocated on the other thread, thread 2 will assume that singleton is fully constructed. That is not the case. The compiler can get us into such situations. In order to avoid this, we have to mark the member variable as volatile so that every thread does not see any locally cached copy of singleton and only reads it from main memory, which means that it will not see a partially constructed object. Let's just put it all together and see how double checked locking plus a volatile member variable looks to create a singleton. So there we have the volatile singleton and the double checked locking as a part of get instance. Okay, that was a lot of work to create a singleton. A lot of little bits to take care of. But we are not done yet. There is some Java specific fine print that we still have to worry about. This deals with class loaders. Class loaders are part of the Java virtual machine, which allows you to instantiate classes and load them into memory. This is what works under the covers in order to get you objects of a certain type. Now, every application typically runs with one class loader. However, you can configure your application to run with multiple class loaders. In this case, if you have more than one class loader, it's totally possible that despite all of these precautions that you've taken with singletons, you can create two singleton objects because you have two class loaders. Now, a class loader is a part of the Java virtual machine, and namespaces are unique per class loader. And class loaders exist exactly once per program. But in the rare case that you don't have one class loader, this is something you need to watch out for. There is a way to get around this class loader subtlety, and that is by using enums. Enums are guaranteed by the Java virtual machine to be instantiated exactly once. Therefore, if you create your singleton using enums, you'll be guaranteed to have just one instance. whether you have one class loader or several. Now, it's a very rare case to use multiple class loaders, so you don't really need to worry about it in regular programming, just something for you to watch out for. Now, creating singletons is tough. There are a lot of issues to watch out for. What if you had a very simple class which does not store state but you don't want it to be instantiated? You'd not use singletons. Instead, you would just use a class where all the member variables and member functions in that class are static. This completely suffices for very simple use cases. All your variables are static, all your member functions are static, which means there's just one instance of the entire class in memory. However, it's not always possible to do this. The order of initialization or instantiation of the member variables in a static class are not deterministic, which means if you want your singleton object to be instantiated and initialized in a particular way, because it's a very complicated class with lots of dependencies, and this is typically the case, which is why it's a singleton in the first place. A simple class would normally not be a singleton. However, going back to static variables and static member functions, if you used such a class instead of a singleton, you'd not be able to predict the order of initialization of its variables, leading to subtle bugs which are impossible to debug. So, if your class really needs to be a singleton, make it one and deal with all the issues. Issues with singletons are well understood. You just need to implement them correctly and be careful how you do it. Understanding and using singletons adds a powerful weapon to your arsenal.